Hello guys, welcome back to Zeph Academy. Today our topic of discussion will be about quadratic functions and we shall be solving them by the method of completing the square. Now, this method has a variety of applications in the cases when using the factor method becomes difficult or complicated for us. In such cases, we shall be using this method to solve the quadratic functions. So let's try to understand this thing into more detail by taking a simple example of a monic quadratic. So this is the question given to you here. Y is equal to x squared minus 4x minus 5. Now completing the square basically tries to create the last term of the given equation in such a way that the equation which is formed, the resulting equation formed, will be returned as a perfect square. So let's try to understand this thing by focusing on the middle term which is given to us here, that is minus 4. So the method proceeds like we have to first of all half this given middle term. So what will happen that it will be written as minus 2 and then the resulting number will be squared, which will make it equal to 4. Now this 4 will be written as the last term in the equation here. Let's see how it is written here. See. And of course, when you add something in the equation, it has to be subtracted at the same time to balance it. And minus 5 will be written as it is. So if you now just try to focus on this part, you will realize that this can be written as a perfect square x minus 2 whole square. And of course, minus 4 and minus 5 will be simplified and written as minus 9. So this is how we can solve the quadratic equation by completing the square method. This was the very simple case of a monic quadratic. Now let's try to understand that what if non-monic quadratics or the questions with the coefficients of x squared are given to you, which are not 1 but something else. Like this example where 2x squared is given to you. In such cases, the process becomes somewhat lengthier because ultimately now the focus first of all shifts to the first term where you have to eliminate the coefficient of x squared to convert it into monic quadratic first of all. So what we will do is that we will first of all try to focus on the coefficient of the first term, that is the x squared. The coefficient here is 2 and we shall be dividing the entire equation by 2. This will ultimately form the equation in the form of a monic quadratic. If you can see it here, now x squared minus 6x plus 8 is resembling to the monic quadratic. And now we will be simply applying the method we used above, in which we shall be once again focusing on the middle term. We will try to take it out, we will half it, the resulting number will be minus 3 and then square it. And that will give you 9. And this 9 will be written as the last term of this equation C in this manner. And of course, once again, you will have to balance the equation by subtracting the same number which you have added it, and 8 will be restored at its desired position. So now, if you try to focus on these first three terms, you will realize that this is a part of a complete square thing and it can be written as x minus 3 whole square, and of course minus 9 plus 8 can be reduced to minus 1. So this is how we will be solving the examples if monic quadratic or non-monic quadratic functions are given to you. So let's try to understand this thing in more detail by taking one example given here. The same question which was given in the non-monic quadratic. Now we shall be solving it. So once again, take that first term into consideration here because this is the case of a non-monic quadratic, and let's divide the entire equation with 2 to get rid of the first term coefficient, which will ultimately give you this result, and then you'll be focusing on the middle term, and this is how you will obtain this 9, which was already explained in the previous part. So your equation will be now written as x minus 3 whole square, and of course minus 9 plus 8 is equal to minus 1, and this 2 will be repositioned here, and this is what your equation will take the form of. Okay, now the remaining steps that we were doing in the previous cases when we had solved the quadratic functions by the factoring method, which was discussed in the earlier tutorial, will of course remain the same, where we'll be finding out the x-intercept by taking the value of y equals to 0. So this is what will be happened here, and this will lead to the equation taking this form, where you'll be getting the value of x as 4 or 2, means two values of x. Similarly, the y-intercept will be calculated by taking the value of x is equal to 0, and that will be giving you the value of y equals to 16. Okay, and once this is formed, the axis of symmetry can be calculated, of course, by taking the average of the zeros, and here the zeros are 4 and 2, which is obtained by calculating the x-intercept, and that will be resulting in the equation of the form of x is equal to 3. This is your axis of symmetry's equation. You just try to replace this value in the given equation here, and that will help you to obtain the value of y, which will be minus 2. So ultimately, the graph formed will be of this kind if you try to plot the values we obtained there. Okay, the points that we have to focus is, now consider this equation that we had obtained before finding the x-intercept and the y-intercept. Now in this equation, if you look carefully, for any value of x I keep here, maybe it is negative or positive or fraction or anything, you will always get the value of y as positive. Let's try to understand that thing by taking an example of a special case when we keep x is equal to 3. In that case, the value of y will be minus 2. That means what? The value of y will be always positive except the case that when x is equal to 3. You can try it out by yourself by taking any example. Let's say that if you take x is equal to 1, then also the y is going to be positive value. If you take x as a negative number, because of the fact that this x is inside a square sign, so the number is always going to be a bigger number, and y will be getting a positive value. So we can easily say that y will be always greater than this minus 2 only when x is not equal to 3. So we can easily say that the graph passes through this point 3 comma minus 2, the value of x that we taken 3 and the resulting value y obtained is minus 2. So this 3 minus 2 is the point through which the graph passes, but it never goes below it. So this point can be termed as vertex of parabola. And yes, x is equal to 3 can be termed as axis of symmetry. So this is one of the ways of finding out your vertex of parabola and axis of symmetry from this equation that we obtained. If we don't want to follow the conventional method, we can easily obtain it by using this method. Let us try to understand this thing by taking one more example. This time we shall be taking one equation with the coefficient of x square being negative. Let's see what happens here. So first of all, we'll try to just convert this thing into a perfect square. The process is explained here briefly, which you can obviously refer here, that how we are obtaining the result here. Negative x minus 4 whole square plus 1. It is explained here briefly. You can just go through it. Now in this case also, once again, if you try to put x is equal to 4, means ultimately our intention is that if we try to convert this bracket as 0, because if we put x is equal to 4, the bracket will become 0. So in that case, the value of y obtained will be 1 if we compute it, right? So except this value 4, y will always be negative for any value. Only y will be equal to 1 when x will be equal to 4. So we can once again say that y value will be less than 1 when x is not equal to 4. Means for the values of x other than 4, y will be always less than 1, which draws us to the important result that once again the graph is passing through this point. X is equal to 4, y is equal to 1, but it never goes above it. So once again this becomes your axis, sorry, once again this becomes your vertex of parabola, and x is equal to 4 becomes your axis of symmetry. So this gives us some important conclusion that if we try to put this thing in general, we can say that for the quadratic given as y is equal to of this form a x minus h whole square plus k, we can easily say that the vertex will be h comma k, and the axis of symmetry will be x is equal to h. This is what we can draw the conclusion from the results discussed in the previous two slides. And these are the alternate methods of finding out the vertex and axis of symmetry from the given equation obtained. So that is it, guys, for today. We shall be discussing this chapter in more details, where the questions will be involving some high powers of the functions and other challenges, but that is in the next class. So till then, take care of yourself. Wish you all the best with the learning, and please do not forget to subscribe to our channel if you like this video. Thank you very much.